If you're lucky enough to be creating a web application from scratch, then you'll have the advantage of being able to choose your favorite technologies and move forward with that foundation. But developers often have to enhance an existing application, and it can be tricky to integrate new technologies into an existing project. In this video, I'll talk about the issues and solutions I discovered while adding new components written with Solid and TypeScript to our large web application. Our existing code base didn't use any framework except for jQuery, which is more of an API. And it doesn't use modules. Instead, each component executes at startup and creates references to objects and functions in the global scope. The complete DOM node structure is created by imperative JavaScript code. It would have been nice to migrate the existing code into a more modern build process, but that was more than I wanted to take on. A minimally invasive approach was to have the new TypeScript solid code build to a single JavaScript file that would be included in the legacy build process. If you're going to use the starter project that I mentioned in a previous video, then you'll probably want to review and change some things. There's so many ways that you might want this to work depending on the details of your project. I'll just point out some of the obvious settings that you may want to change in this project. I'll put some links in the video description for various components used by this project. So the project README contains a little information about the build process and shows the commands to start the development web server and build in various ways. Now the package.json file is the main node project settings file. You'll want to change, the project name and description, author and things. But the section at the bottom configures the Babel preset-env plugin. So let's see, they describe this on their site as Babel preset-env is a smart preset that allows you to use the latest JavaScript without needing to micromanage which syntax transforms, and optionally browser polyfills are needed by your target environments. The targets parameter supports various ways you can specify the browser versions the app will support. Our application only targets one specific browser version, Chrome version 69. tsconfig.json is the TypeScript configuration file. You should review the target parameter that specifies the ECMAScript version to target. My TypeScript video touched on this parameter. At the bottom, the exclude parameter specifies files and folders to exclude from compilation. Your project might need something different. So the webpack config.js is webpack's configuration file. And webpack performs tree shaking to eliminate unused code. And it also resolves, module references. The entry parameter specifies the entry point or points to the application. And this is where it starts with this tree shaking. So, only modules that are required by this file and all the other dependencies will be included in the output bundle. Now the output structure specifies the resulting JavaScript bundle file. Production build produces tsbundle.min.js, which is very minified. A development build produces tsbundle.js and contains source maps for debugging the original source in the browser. This video is about integrating solid components into an existing web application, so the project's index.html file isn't necessarily needed, right? Because your application has its own HTML file. But when you're first creating a component, it may be faster to start in a standalone project like this to get basic or even complete functionality before integrating it into your main application. It may even be a good place to create a test page for all your solid components, but I didn't have time for that. And once the component was integrated into the main app, functionality diverged. So now changes are always tested in the full app. But I'll use this, HTML file and project again when I'm, launching a new component to kind of just get the basics down. And a project that wants to invest in testing could create a full test suite for their components in this project. To make it easy for our main application's build process to include the output JavaScript bundle from this project, I put this project and source in a subfolder inside the main project source. Our main make project was modified to build this project whenever any of this project source files changed. So of course you have to reference the bundled code in the application, either by including it directly or somehow including it in your own bundling process. The first line here was necessary in my case because Solid correctly refers to the global object using global this, but the browser version we target doesn't support that yet. So JavaScript running in the browser can access global scope using window, but now that JavaScript is popular on the server as well, a better name was needed, and global this, I think, was chosen. So that first line allows Solid to reference the global this object in our old browser and, get to what the browser likes as window works as the browser's reference to the global object. And then here you can see it just includes the bundle. Right. Now, I thought that initially I thought that since the new code resulted in pure JavaScript, the old and the new would be able to directly interoperate. But because of the way that webpack resolves modules, I couldn't figure out how code outside the bundle, our old legacy code that doesn't use modules, how it could access functions inside the new bundle. So I solved the problem by having this code execute when the bundle is loaded, by the browser, and it creates references to functions that I want to expose. So this is in the TypeScript project. And I named this file, I created a file, I named it global tsexports.ts. You can name it anything. And the webpack config file refers to this file as the entry point to the application. And I mentioned the entry point parameter, the entry parameter a minute ago. And it first imports the functions that I want to create, that I want to expose. And as far as I know, TypeScript doesn't have a standard way to access the global object, but simply declaring window as type any, we're telling the TypeScript compiler to let us write whatever code we want using window and pass it through as is to the resulting JavaScript. Then it creates an object named tsexp, which I call, it's my short name for TypeScript export. And it creates this object in the global scope containing references to the functions I want to expose. So this will be loaded by the browser out of the bundle, right? It's not part of a module or anything, and so it'll execute as soon as it's loaded, and it will basically create this object at the global scope so the legacy code can access it. So in your legacy code, you can now invoke the TypeScript functions that have been exposed in the tsexp object at global scope. This example code calls the functions to create the store, and it just references that object, .create store, and then calls functions, the function that renders the solid component, passing it the element to render under, and the store. The legacy code now has access to the store and can update it to affect changes in the new solid control. And, that's why I created it outside of kind of the TypeScript environment, because I need the legacy code to be able to, update the store. So this worked really well. Now the legacy code is all accessible from the global object, so TypeScript can access them fairly easily. But the best way to do that is to create type declarations for those legacy functions. My TypeScript video describes the basics of type declaration files. So I created a file called static.jstypes.d.ts That's the convention for type declaration file that contains the type declarations for the legacy functions that I want to call from TypeScript. Those legacy functions are nested in object structures. So to match those structures, you declare the functions as part of namespaces with the same paths. So, in the legacy code, there was, at global scope, there was, would be, like in this case, you just called it XYZ. There was an XYZ object that contained, an SVG button function. Then when you declare the functions that are in that object, well, that's right, that's not a function. So xyz.svg button is, there were kind of two nested objects, and then within that object, there's a get image URL function, and then an object icon image. And so by declaring it with this namespace that matches kind of the structure of the, the object nesting in the, the global scope, it works. Now, placing this file anywhere in the TypeScript project allows Visual Studio Code to pick up these types so you can use them anywhere. So here's an example of a specific type declaration from the previous slide and the code that uses that type declaration to call the legacy function. And so, right, this is in the TypeScript where it just, because I created this declaration, this is all gonna be nicely, with the code, autocomplete and things, and it'll, make sure that I have the right types. So it's simply invoking that function, and it knows that it returns a promise that doesn't return any data. So it's this is really nice to make the legacy code kind of play in the TypeScript world very nicely. So I hope this video will help anyone who wants to integrate Solid and TypeScript into their existing web application. In the end, it works very well, and you can use these very modern and powerful tools without having any negative impact on your existing application. And this is particularly important when selling this approach to management and coworkers.